Good afternoon, Professor, student, and everyone. Our group has chosen to work on the touchscreen technology, primarily because it's widely applicable in various business situations, and also with the recent popularity of the iPhone and iPad and also the smartphones, we find touchscreen technology are of great potential in the future. And we hope that by the end of the presentation you can pick up the core concept of our research project, that what exactly is happening when you touch this on your smartphone, how the screen sends your touch. Okay, and we have tried very best to make the slides very easy to follow, so I think it's a very clear and easy concept to pick up. So why don't we start with our outline, just go through all of them. Okay, here is the core value of touchscreen. I think the key thing of touchscreen is to eliminate the need of an input device. In the past, say when you're using your computer, you need a mouse or a keyboard to make your input in the system. But however, with the touchscreen, you can replace the input device with your finger, and that's bringing us a lot of convenience. I have to follow closely with this slide. Okay. So there are actually different kinds of touchscreen technology, and we are focusing on mutual capacitive, which is the kind of touchscreen technology that you find in iPhone and other smartphones. And the main device in this technology is a capacitor. For those of you who study physics, I think you know this capacitor very well. And what exactly is a capacitor? We'll let you know the structure. Let's take a look at the structural layers of an iPhone. With the innermost 3 layers is a capacitor. So how the capacitor can act as a touch screen and sense your touch, it needs let's show you everything first. In class, we learned that signal is variation of some physical quantity over time. So with the capacitor, with the accumulation of electrons, it has a voltage exists between the capacitor. And with that voltage, when you touch on the screen, it can discharge the electron, and a change of voltage would happen. And that is an input analog signal in your mobile device. So let's take a look at the flow chart. So with the capacitor, a voltage exists between it, and when your finger touches on the screen, since your finger is the conductor and will discharge the electrons, and a sharp decrease of voltage would happen, and thus your touch is detected. But this is not the end of the story, because you still need an accurate calculation of that position. So we need to remove the background noise. Since what we collected is the raw data, and you need to remove all the background noise to have an exact coordinate of your position. Okay, so that's how you get an analog input signal of your touch. And now we need to relate your input signal to and a command to the application that you're using.
So in the previous slides, we have discussed how the capacitor captures your touch and it turns it to an analog signal. So in this part of our presentation, we will discuss how this analog signal will create commands to the applications and hence to your output device. After the analog signal is generated, it will go through an analog to digital signals and convert the signal to a digital signals. And the processing device, that is the CPU, will interpret the signal as a command to the applications, and the output device, which are the screen and the hardware, will perform as desired. We will use iPhone as an example and go through the whole process. As you can see that the signal is captured, and then the CPU will process your input and relay to the corresponding applications. For iPhone, it uses a gesture interpretation software to determine which gesture you made. And then it combines with your physical movement with information about the application you were using and what the application was doing when you touched the screen. And then it sends the command to iPhone screen and other software, and they perform the desired function according to the touch input signals. But sometimes, if the raw data does not match any of the touch of or the application, iPhone will just simply discard your touch. That's why sometimes when you touch your iPhone, it doesn't respond to you. And Sharon will further illustrate with the example of picking up a call.
Thanks, April. I'll illustrate to you how we touch to receive a call. Say, one day, you receive a call from Steve Jobs and you want to pick up the call. So, you tap the answer tube, and as you touch the screen, the device measures a change in voltage and touch is detected. It further calculates the coordinates of your touch. The CPU then relays the input to the application. It will interpret the tap action as select and also the location of touch as the answer call button. The processor will connect the call and call interface is displayed. So now you'll receive the call and say, "Hi, how are you?" to your friend. And I have just illustrated to you the application of touchscreen technology to iPhone. But touchscreen technology does not only apply to iPhone. And have you ever thought of stretching and shrinking the touchscreen? Using a touchscreen with your friends face to face? Or reading news and schedule while brushing the teeth with mirror in front? Actually, all these are gonna happen in the future as the touchscreen technology is still developing. And now I'm going to show you how this will be like in the future. Please enjoy the video.